Hi. One more piece that we want to talk about as we're talking about statistical and practical significance is the correlation issue. I'm fairly certain that you would have heard that correlation is not causation. But what does this actually mean? And why is it one of the most important things that you need to think about as a data journalist? Because correlation and causation is a significant temptation and an issue and needs to be handled with care when you're a data journalist, as well as when you're a scientist or a policymaker or anyone else working with data. But correlation is not causation is particularly tempting to violate as a data journalist. And that is because correlation between two indicators or two variables is a statistical term that means when one of these variables changes, it's very likely that the other variable has a predictable change. Many variables are correlated. When the heat goes up, ice cream sales go up. Those two things are correlated. It's more likely that people buy ice cream when it's hot out. We've seen a correlation in our Tableau visualizations between the income of a country and the proportion of people in that country that have access to clean water. There is a relationship. When GDP goes up, the number of people in that country who have access to water goes up. That's a correlation. Causation is an entirely different thing. Causation means that a change in one variable is actually causing the change in the other variable. So if we go back to our example of when the temperature goes up, the sales in ice cream go up. Common sense tells us that that's probably a causal relationship, but there's no way to actually test if something is causal if you have regular observational publicly available data. If you have a randomized control trial or a strict scientific experiment, there are ways to talk about causality based on what the data can tell you. But if you have data from anything other than a scientific randomly controlled trial, which is 99% of the time what you will be working with, you can't tell from the data whether causality is real or not. If we go back to our heat and ice cream example, when temperature rises, the percentage of ice cream sales is also rising. In an unrelated situation, we also find data that shows that when the temperature rises, the murder rate rises. People are more likely to murder each other when the temperature rises. If we look at these two datas together, it is common sense that these two things might be causing each other. A rise in temperature might be causing an increase in ice cream sales, and a rise in temperature might be causing a rise in the murder rate. However, if we take these two variables, they will also be correlated. So a rise in eating ice cream is correlated to a rise in the murder rate. So we can definitely say, statistically significant, that a change in the amount of ice cream being consumed in a country increases the murder rate in that country. However, it's probably not causal. This does not mean that eating ice cream is actually causing the murders. There are many websites available today that have examples of hilarious correlations. The Nobel Prize and eating chocolate example is a very fun, enjoyable example. However, it's not a joke. It is a real problem because the examples that people put up on these websites that say, clearly these relationships are not causal because we don't believe that they're causal, isn't really illustrating the depth of the problem, because the depth of the problem is we only think that these things are not causal and that they're funny because they conform to our worldviews. There's nothing in the data that can tell us whether these correlations are actually causal or not. If you really want to to be able to say something is causal, and you don't have a randomized control trial or a scientific experiment, there's a couple of things that you can do. You can show causality, or more likely support for causality, by showing consistency of association. If you collect data on two variables in a number of different settings from a number of different people, and they're consistently correlated, that makes you think this relationship probably is related and might be causal. The strength of the association. If a change in the first variable causes a significant, large, sustained change in the second variable, and it lasts for a really long time, you're more likely to think, okay, that might be a causal change. The temporal relationship. So if you can get data that shows where they're happening in time. So in other words, if we're trying to understand the relationship from our previous example about the size of the police force and the crime rate, we know that when the size of the police force is large, the crime rate is large. Is that because the large police force is causing the large crime rate? Or is the large crime rate causing the large police force? Or are they kind of iterative? So if we can see them over time, a temporal relationship, we can see that a rise in crime is causing a slight increase in the size of the police force, which is causing a slight decrease in crime, and then crime goes up again over time, which causes an increase in the police force, and then the crime goes down, and then maybe the crime goes down a little more, and then maybe they get money and they decide to invest in a different kind of police force. So looking at the data over time is one of the best ways to talk about causality. And then finally, you really need to understand the mechanism. If you want to say that something is causing something else, you really need to understand how it's doing it. And that's where we get really into the data journalism. That's where we get into the storytelling. So this data, this observational data, can say, yes, these two things are correlated. When this variable changes, this variable changes as well, and it's consistent and it's happening over time. Now we need to go out, talk to the people that this data represents, talk to the institutions, visit the people, places, and things that are being represented by this data, and find out what the causal mechanism really is. That's why data journalism is such a great way to tell stories based on data, because you have an access to the causality, the causal reasons, in a way that the data just can't give you. So statistical significance, practical significance, and correlation is not causation are three statistical thinking principles that you really need to kind of put on a post-it note next to your bed or next to your washroom, because you need to be thinking about them pretty much constantly if you want to be telling stories with data.